Okay, students, the last part of Module 5, that is Scalable Clustering Algorithms. Uh, Now we have seen what is density-based algorithms, what is graph-based algorithms. Last we have is Scalable Clustering Algorithms. So, now even the best clustering algorithms, they have little value sometimes because it requires too much memory. Okay, so here in this we give more emphasis in scalable clustering, we give more emphasis on the scalability of the data sets. So how do you generally scale the data sets? What are the strategies for scalability? It can include how reducing the proximity calculations, or maybe sampling the data, or partitioning the data, or clustering some representation of data. So two main scalable clustering algorithms are Cure and Birch. These are the two scalable clustering algorithms. Okay. Now we'll see what is Birch first. So Birch stands for Balanced Iterative Reducing and Clustering Using Hierarchies. So it is a good efficient clustering technique. Birch is efficient clustering technique for data in the Euclidean space. That is for data when the mean value makes some sense. Okay, it can cluster the data with one pass and then improve the clustering with additional passes. So here we construct CF tree. CF tree is a clustering feature tree which is being constructed. So here the idea is to cluster a cluster of data points which can be represented by a triple of numbers. Triple of numbers, what is the triple is? It is nothing else but we represent n, ls and ss. Okay, this triple where n is the number of points in the cluster, ls is the linear sum of the points, okay, and ss is the sum of squares of the points. Okay, so based on this triplet we are going to represent. Then what is a CF tree? A CF tree or a clustering feature tree, it is a height balance tree. Okay, so this is first of all a CF tree is built as the data is scanned. So as each data point is encountered, what happens is the CF tree is traversed starting from the root node and choosing the closest node at each level. So when the closest leaf cluster for the current data point is identified, a test is performed to see if adding that item in the cluster will result in a new cluster with a diameter greater than the given threshold. Okay, this is what we perform in this. If not, then the data point is added to the cluster by updating the CF information. And the cluster information for all the nodes from leaf to the root will also be updated. Okay, so Birch follows each split with a merge step. So at the interior of the node where the split stops, the two closest entries are found. If these entries they do not correspond to the two entries which resulted from the previous split, then an attempt is made to merge the split and the corresponding child nodes. So this is what we do in a Birch algorithm. So I have the algorithm over here. First is you load the data into memory first by creating a CF tree which summarizes all the data. Next is you build a smaller CF tree if it is necessary. Okay, for phase 3. So here at this stage, the tree T is increased and then the leaf node entries are reinserted. So since T has increased, some clusters will get merged. Okay, the second step. Then we perform global clustering. Like agglomerative, hierarchical, different forms of global clustering are there. So here they normally use agglomerative and hierarchical clustering because the clustering information will store summary information which is important for certain kinds of clustering. So here what are the two clustering techniques which are used? We are using here agglomerative and hierarchical clustering, basically to store summary information. Okay, that is why these two techniques are being used. Then redistribute the data points using the centroids of clusters discovered in step 3 and thus discover a new set of clusters. So this overcomes a problem which can occur in the first phase of BERT because of page size constraints and the T parameter. Points that should be in one cluster are sometimes split, and data points that should be in different clusters are sometimes combined. Also, if the data set contains duplicate points, these points can sometimes be clustered differently depending on the order in which they are encountered. Okay, so by repeating this phase multiple times, the process converges to a locally optimum solution. That is what they do in Birch algorithm. Okay. Then another one which is a scalable algorithm is a CURE algorithm. CURE stands for clustering using representatives. So it is again a clustering algorithm which uses a variety of different techniques to create an approach wherein you can handle large data sets. Okay, and clusters non-spherical shapes and non-uniform sizes, because these are some of the disadvantages of the earlier clustering techniques, that they can only cluster spherical shapes. Then it represents a cluster by multiple representation points. The first point is chosen to be the point farthest from the center of the cluster. Okay, while the remaining points are chosen so that they are farthest from all the previously chosen points. So in this way, representative points naturally relatively get well distributed. And once the representative points are chosen, then they are shrunk towards the center by a factor alpha. Okay, so this is the procedure which is being followed for CURE algorithm, and algorithm is given over here. First step is they collect a random sample from the data set, then partition it, then cluster the points in each partition, then use the hierarchical algorithm and cluster them into M by Q clusters, then eliminate outliers because we don't use outliers for clustering, and then assign all the remaining data points to the nearest cluster to obtain a complete clustering. Okay, so with this we come to the end of module 5. Okay, thank you.